arc length. Yeah, let's do something kind of obvious. Let's say your RT is 0, 3 cosine t, 3 sine t. And the question is find the arc length from t equals to 0 to t equals to 2. Now, x equal to 0 means which plane is it on? The entire curve belongs to one plane. Huh?
YZ.
YZ plane, right? So if you have x, y, and z, and if you only look at the points where x is 0, if x is 0, then you only have freedom to move in the y direction or the z direction, so you end up with the YZ plane. So this curve only lies in the YZ plane. What kind of curve is it?
Circle.
It's a circle because you recognize cosine and sine, right? So it's something like this. Okay? Circle of radius 3 centered at the origin. Right? How do I know that it's radius 3? Because of this 3, right? Okay. If I put something in front of t, it doesn't change the shape of the circle. If I put 2t, for example, it just changes how fast it's moving in the circle. Right? So this is a circle of radius 3. So you actually know the answer before doing any calculus, right? What's the answer?
Would it be the circumference of the circle?
Because it's 0 to 2 pi, right?
Yeah.
What is it?
2 pi r.
2 pi r. And what's r?
3.
3. So what's the
yeah.
answer?
6 pi.
6 pi. It has to be 6 pi. Okay. So we know that the answer is 6 pi, but this is just a demonstration how the formula works. So I want to show you the calculus 3 way of doing it. And because we already know the solution, if it agrees with the already known solution, you kind of understand the whole mechanics, right? Okay, so let's try it. All right. Here's the idea. If you have dr that's the change in the position, right? Small d means it's a change in position. Now, if you take the small change in position and take the norm of it, it gives you the distance traveled. So here's a picture. If you have some curve, if I divide this into very, very small parts, each of these small one is called dr, and it's a vector. Okay? But if you just want the length, you would take the norm of it and call it ds. Now, if I want the entire arc length, usually denoted by lowercase s, capital S is for surface area, and lowercase s is usually for the arc length. Okay. Then the calculus way of figuring out any quantity is to say anything is sum of its parts. So in other words, if you add up these small things, and then they all add up to this large thing. So anything is sum of its parts. That's how you do it. But the thing is, we don't know how to calculate this. So we first rewrite it as ds over dt and multiply by dt. So divide by dt and multiply by dt. And think about how to make sense out of this quantity. What's ds dt? That's dr dt. And if you assume that dt is always a scalar that's positive, you can just put it inside the norm. So we have the following formula. S equals the norm, the integral of dr dt by dt. Now, even if you didn't really understand what was going on here, you can still make another physical argument out of this. What is dr dt? Huh? Velocity, right? If you take the norm of the velocity, what do you get? Speed. Okay. And if you do speed times time, what do you get? Distance traveled. Right? So really what's going on in this formula is the following fact. If I want the distance traveled over a very short period, then what you want to do is, see this much is really the speed. Okay. And speed times this small bit of time gives you the small bit of distance traveled. Okay? And that's what I'm adding up. The integral sign is the letter S, right? It means you're adding them up, sum. The letter S is used, this is really letter S for sum. So if you add up these small bits, you end up with large, which is the total arc length. Okay? So that's how it works. And to demonstrate that it really works, let's actually apply it to this problem and see that it gives us the 6 pi that we thought it should get. Okay? All right, so the actual solution, not from here, actual solution starts from here. What you need to do is first find dr dt. You find the velocity. I have to differentiate these, so it's 0, -3 sine t, 3 cosine t. And then I take the norm of it, because that gives you what? What's the norm of the velocity? Speed. Okay, so that gives us a speed, which is square root of 0 squared plus -3 sine t squared plus 3 cosine t squared, which is square root of 9 sine squared t plus 9 cosine squared of t. Well, what's sine squared plus cosine squared? If I factor the 9, what do I get? Sine squared t plus cosine squared of t. What's this? It's 1, right? So that's just 3. Oh, that's easy then. My arc length from t equals to 0 to t equals to 2 pi is to integrate dr dt norm dt. That's the formula that I have to use. Well, we just calculated this much, and it turned out to be just 3, right? So that's 3. And then we integrate 3, you get 3t. You plug in 2 pi and 0, you get 3 times 2 pi minus 3 times 0. That's how you do the definite integral, right? That's 6 pi minus 0, which is just 6 pi. Exactly same as what we thought it was. Now, the fact that the speed comes out to be a constant is not anything special at all, because we already know that this is going around in circles in the same speed. It's never speeding up or slowing down, right? So if we were to calculate the AT, the tangential component of the acceleration for this one, you'll find that it's 0. Okay? Well, you can already see from here, if you differentiate the speed is 0, so tangential component of the acceleration is 0, that we know. Okay? I guess that's all I have to say. Do you have any questions? It's kind of straightforward. Right?